to see something cool, man? I think I could put this olive into this glass without using my hands.
How?
Physics. So the way I'm going to do this is I'm going to put this glass over top of this olive.
Good. Wow.
Yeah, that's pretty cool.
How did you do that?
I don't know. Let's go find out.
Hey Yanir and Marco, glad you asked that question and glad that you came to us for a solution. So the way that we're going to be showing you centripetal force is we are going to be taking a quarter and a balloon, and we're going to be showing with this quarter and balloon how centripetal force works and how that olive got picked up by that glass. So the first thing I'm going to do is I'm going to take this quarter and I'm going to put it inside the balloon. By blowing up the balloon with the quarter inside it, I will now be able to spin it. When I stop it, it continues moving in this horizontal motion, staying on the outside surface of the balloon. This is exactly like how your olive works. It's going to stay on the outside of the balloon because there's an inward force working on the quarter. Now I'm going to give it off to Marco.
So if we tie this into the balloon and the quarter, or even in your case, the olive in the cup, we can identify that there must be a force driving it toward the center. We call this centripetal force. Okay? Fc. The mass has to be constant, the velocity must be constant, and the radius must be constant, but the velocity is squared. And we know from forces that when anything is on a surface, there is always a force called the normal force. Meaning that the centripetal force is being fed by the force driving from the surface through the quarter and into the center, or from the lining of the cup through the olive and into the center of the cup. So if we, I'll show you with the balloon, I'm showing, if we spin this enough, there's going to be a large amount of tangential speed. This just means the velocity going in this direction, this direction, this direction, and so forth, causing this perfect uniform circle. And if the radius speed remains constant, then this force is always driving it toward the center. And it makes sense. Say you were playing soccer and you wanted to pass a ball, and it's going this way, right? And then the person that you passed it to tries to pass it this way. Where does the ball go? The ball goes this way. And if somebody here passes it this way, then where does the ball go? It goes that way. And if you can continue to put that force through it, you get what is a pretty circular thing. Now what is happening here is it's affecting it every degree along the way. So there is a force pushing through this quarter, always causing it to do this perfect uniform circle. Finally, we can conclude that the centripetal force is equal to the normal force that is being supplied by the lining of the balloon. And finally, Fn will then be equal to mv squared over r.